The next question of CodeChef starters 117 is not prime permutation.
Okay, so in this question there is no chef. I guess we'll miss chef in this question. So coming to the question, in the question we'll be given an array, let's say P, and what question expects us to do is build one more array. Okay, build one more array. Okay, well, let's say what P contains first. P will contain integers. If P is of size n, P will contain integers or permutations from 1 to n. Okay, and what he expects us from the question is we have to return an array of same size n by arranging whatever elements we have in P such that a P of I plus A of I is not a prime.
Yeah.
P is not a prime. We have to make such AI. A is uppercase in my life. Such that P of I plus A of I is not a prime.
Yeah.
Let's look at few test cases to be more clearer. The third test case. Here, coming to input format, will be given T test cases, N and P array.
Yeah.
T is number of test cases, P is size, and N is size, and P is the array, input array that will be given. Permutation will be given. So coming to one sample input, let's say 5 is the size of the array, and permutation is the given permutation is 25134, which is the third sample input I'm talking about.
Yeah.
Sample IO. So in this case, we have to generate an array of same size such that this is P, this is A.
Yeah.
0, 1, 2, 3, 4.
Yeah.
Okay. We have to write such an array such that, as I said, P of I plus A of I, A again uppercase, is not a prime. Okay. So answer he gave, let's see why his answer is correct. Answer he gave a sample output is 4, 1, 5, 3 and 2. If you add 2, 4, it will be 6. If you add 5, 1, it will be 6 again, 6 again, 6 again and 6 again.
Yeah.
If you see all the numbers which you got after addition is not a prime, are not prime. Or looking at it from a different perspective, these are all even numbers.
Yeah.
And one more POV point of view of looking at this is all numbers are even numbers.
Yeah.
So our answer can be possible. He said if there are multiple answers, you can print any, and if there are no answers, you will print -1. Let's see in what case will you get -1. Let's say n value was 1. Only permutation input possible is P equal to 1. And only array which will be possible is 1.
Yeah.
If we add these, we'll get 2.
Yeah.
We know 2 is a prime number.
Yeah.
So for n equal to 1, we will get answer as -1. Okay. Let's say for n equal to 2, what it does? Only permutation possibles are 1, 2 or 2, 1, correct?
Yeah.
And according to these permutations, arrays possible can be 2, 1 or 1, 2.
Yeah.
Same for this 1, 2 or 2, 1.
Yeah.
No matter how we add, we'll only get 2 or 3 as sum,
yeah,
which are primes.
Yeah.
So for n equal to 2 also, no matter what permutation, no matter what array you get, answer will be -1. That means we can never get an array such that P of I plus A of I is a prime.
Yeah.
Is a not prime. So for two test cases, we have to handle separately. For n equal to 1, n equal to 2. Answer will be -1. For all remaining test cases, we can generate answer. How? We'll look in a while.
Yeah.
Or we'll look now itself.
So here, as discussed, we just saw that for n1 and n2, it's -1, right?
Mm-hmm.
N is equal to 1 and n is equal to 2. For these, the output is -1. As we just dry ran all possible cases, and we could see we could never achieve it. And now the claim is if n is greater than 2, it's always possible. So let's see how it is possible. So I'll just pick one random permutation for now. Let's say n is equal to 6. With this, let's say it's 6, 3, 2, 3, right? So we'll output and 4. Here it should be 4. So now we'll output a permutation A in such a way that no, if we add the same corresponding index values, that shouldn't be a prime, right? So for that, let's analyze one thing. Firstly, we know that 2 is the only even prime that is there, right? Correct. Apart from 2, there is no even prime. Rest all prime numbers we have, they are odds on the question, right? Why? Because for any even number, 2 will always be a factor. So, and all others are odd primes. So now we can use this fact. What we'll do is we'll pick a permutation in such a way that when we add numbers, we always get a even number. For that, we can observe one thing: adding to even numbers, the result will be a even number. Adding to odd numbers, the result will be a odd number. Even number. Sorry. Adding to even, the result is even. Adding to odds, the result is even.
So you're saying the goal should be not to make all numbers non-prime.
Yeah.
The goal should be to make them odd.
Yeah, even. To make them even. If we
But
make
not
them
to.
even, but
Okay.
not.
Okay. Yeah.
So our aim is firstly, because there is only one even prime, we'll try making all the AI plus PI plus AI sum to be even. And in these even numbers, we should ensure we don't get 2 as a prime, right? 2 as a number. So here if we see, the only way that we could generate 2 as the sum is by placing 1 and 1, right? Rest all the cases we can't generate. So for this, what we can do is we already handled n1 and 2 cases, right? So now we can guarantee that if n is greater than 2, there will exist at least two odd numbers, right? So what we can do is instead of 1, for a 1, instead of 1, we can put any other odd number. So I'll just write any odd. Now wherever we have even among these, we handled 1, what to put. Now wherever we have even in these numbers, place a even number only. Correct. And wherever we have odds, place a odd only. Why? Because we are just putting one more permutation. That means P is also permutation. That means number of evens and odds should be same. Right? So now let's see one possible way to fill it. For 1, I'll just put a 3. 3 is a odd number. Right? Now 6 is even. So I'll put 2 here. 3 is odd. So I'll put 1 here. 5 is odd. And here we already kept 3. So I'll put 5 here. 2 is even. So we can put the next even, which is 4. And 4 is even, which is 6, right? This is one possible way to arrange it. There are many possible ways. So you can output any one of them. So here main thing is ensure 1 won't get paired with a 1. And fill it in such a way that 1 won't get paired with a 1, and then fill it in such a way that for every even you put a even only, such that the sum is even, and for every odd you put a odd only, such that the sum is even. So from this, if you look over, we can see everything sum will be even. This is 8, this is 4, this is 10, this is 4, this is 6, and this is 10. Right? Everything has a sum even, and there is no 2 because we ensured 1 and 1 won't get paired. Right? So this way we can just arrange it. And let's just dry run for n3 as well, because that is the smallest number from which answers are possible. N is equal to 3. So let's take a permutation 312. So in the case of 312, as we saw, there are two odd numbers, right? So because there are two odd numbers, we can always put uh, a number which is not equal to 1 corresponding to the 1 present. So we'll put a 3 here, put a 1 here, and put a 2 over here. This will ensure the sums are even and 1 is not paired with a 1. So this way we can just construct the sequence and A permutation.
One more thought. Instead of putting it as any odd number, can we just say if we encounter 3, put 1. If we encounter 1, put 3. Will this also work?
This will also work. So one more way to construct it is wherever you have a number, place all the numbers. Let's say in P, you have some number P of I, right? At P of I, place A of I only. Uh, like at P of I, in place of A of I, place P of I only, the same number. And only in the case of 1 and 3, swap those two. So what we can do is, simple way to implement it would be, let's take the previous case only, 3, 6, 3, 5, 1, 2, 4. So to construct it, we can just put all the numbers as it is, and then swap 1 and 3, correct? Or 1 and any odd number, that is sufficient.
If you just swap 1 and 3, it will be fine.
Yeah, because if two numbers are same, then for sure the result will be 2 into that number, which will be even. Right? So if you look at the time complexity of this, it's big O of n. Correct. And space complexity, we can implement it in big O of 1 or big O of n. If we don't maintain a list to store them, it's big O of n.
Okay.
If it's big O of 1, otherwise it's big O of n.
If we directly print it, we don't even need an
Yeah.
extra space.
Yeah. So this is per test case. And here it's if you look at the constraints, it's guaranteed that n depends on the test cases. So let us go to the constraints. Yeah, here n depends on the constraint. N depends on the test cases. It's mentioned n will be, sum of n will be at max 4 into 10 power 5. That means we can assume two test cases are given with n perfect 2 into 10 power 5. This will be the worst. And ON is sufficient enough to pass that. So this way we can solve it.